We live in a world where we have virtual assistants now. So Siri or Google or Alexa, or people have assured me that Cortana is also a thing. I wouldn't know. But sometimes when I talk to these programs, I get exactly what I wanted. But sometimes when I talk to them, they don't understand me. Yeah, I can ask the question, do computers ever understand anything? Is it possible for a computer to think, or are they doing something totally different? Let's consider. Hello, philosophers. I'm Chico. Welcome to the Philosopher Show, where we consider the greatest questions of human history. Now, if I were to look at a rock and I whisper to it, "You're stupid and nobody loves you," that wouldn't be wrong of me. It's not like I'm offending it because it doesn't understand what I'm saying in the first place. But if I were to look at a human and do the same thing, that would be wrong because they get it. But what about if I were to say that to a computer? Sometimes a friend of yours will go on their phone and be like, "Siri, you're stupid and nobody loves you," and then see what Siri says. Well, if Siri understands what you're saying, then that's the wrong thing to do. That would be hurting Siri's feelings. But if Siri doesn't understand what you're saying, then it would be much like the rock, where you could say whatever you want to Siri, and Siri might be responding to you, but it's not like you're hurting Siri's feelings. So the question is, do computers, or really could computers, understand anything? What do they do when it seems like we're speaking to them in a language? Can they understand languages? Today we're going to talk about one of my favorite, I'm really stoked because this is one of my favorite thought experiments in philosophy, the Chinese room experiment. It was developed by philosopher John Searle, and he specifically developed it to show that there can be no such thing as artificial intelligence, that computers do not understand what's going on with them, and they could not understand what they are doing, even if they use language exactly like it should be used. Of course, there are people who think the opposite, that think that artificial intelligence is possible and that computers do understand. And by artificial intelligence, I mean like computers understanding what they're doing. They do believe that that kind of a thing is possible. We'll look at five major types of responses today. This is going to be kind of a longer video. This is a lot to talk about. If you really want to, if you're like, I got a specific response I want to see if he goes over, in the description, I'll list out times where I start to talk about each different response. Because if there are more arguments that I don't go over, more responses that I don't go over, and you want to know about them, hit me up in the comments on my website, philosopher.com. I want to explore this a little bit deeper because this is a massive project here to talk about the Chinese room arguments. One argument is crazy that it could be so fecund, but lots of people have written on this thing ever since it came out. And I believe it came out in the 80s, but maybe earlier. I don't know. Any case, let's get into it. Now, in order to truly get this argument, to make sure that we don't confuse ourselves, I want to lay out some definitions first. You may want to write these and keep them next to you somewhere. I'll have these also in my notes sections on my website. But we're going to lay out a few definitions. They're not going to be super precise like philosophers like to do. They're going to be just gist of it kind of definitions. First, let's talk about the word understands just in general. When I say understands, before I start doing philosophy and I say I understand that, or I understand English, or I understand calculus, or you'd be lying. But if you say that kind of thing, whatever it is that you're referring to, that we'll call understands. Just simpliciter. So that's what we mean by understand. And we might be, confused about that concept. That's okay. Just we're gesturing in this area and that's what we're talking about. But I'll make a difference between that and P understands. When I talk about something P understands, what I'll mean is that the understanding includes running a program that produces behaviors that we typically would associate with understanding whatever thing that is. So for example, especially this is the one we're going to be talking about today, if you understand a language, when I say you understand a language, that will mean that you run a program that causes behaviors to come about that we typically would associate. We'd say, he understands that language. Now, the word program, when you hear that, you associate it typically with computer program. this that will be part of this too. But when we say program, we'll mean just a set of rules that you can run algorithmically, without thinking about it, and just go through these rules, and you get some input and you produce a specific output, or even, a specific range of outputs or something like that. And I'm calling it P understanding. That P will stand for programming, program understanding. And notice in this definition that I've got here, I use that word understand, like, when we associate with understanding that thing, that does not preclude P understanding from being the only kind of understanding. Maybe it's the case that when we use that word, I understand English, I just mean that I P understand English, or that's just what we're referring to. That's just what we're gesturing at. That's a possibility here. We're leaving that open with this definition. P understands just makes sure, P understands just makes sure that whatever it is that we're talking about when we say understanding, it includes this aspect of it, this criterion. I also want to define a word, our understanding. When I say our understanding, I mean that when we're referring to the word understanding, whatever it is that we're referring to, I should say, by the word understanding, it includes at least one of the following criteria. Number one, the qualitative aspect of understanding, that sort of, if you're in math class and finally the teacher finally explains it in a way that you get, and you're like, oh, I understand. Whatever that feeling that you get, that we'll call the qualitative aspect of understanding, that sort of deep kind of a feeling we usually say, Another criterion that we'll throw in there is the consciousness criterion, that I am aware of understanding something, and I'm aware of how I can use that understanding. I don't have to be aware of everything, but at least there's some kind of awareness there of the understanding, the conscious aspect of it. And then finally, intentionality criterion. And by the intentionality criterion, I don't mean I'm just going to be intentional about this. That's a different kind of use of the word intentional. Here we mean something more like aboutness. So my understanding is, or the thoughts that I understand, the concepts that I understand have some kind of mental content to them. So if I were to say something like, I understand how a microphone works, my thoughts on this in this understanding are about a microphone. And notice, like, typically we wouldn't say that physical things are about anything. I wouldn't say, what is this cup about? That sounds weird. But if I could say, what are you thinking about? That makes sense. Or what does the word, what is this sentence about, or something like that. That's usually where we use the words intentionality in philosophy to mean. And the letter R here will stand for realist understanding. And the reason I don't like that term a ton, because it sounds like, well, I'm a realist about things. And it's not meant to be like that. Typically, a realist will say that whatever thing that you were talking about, for example, universals, or in this case, consciousness or intentionality, these things are real. They're not reducible to something else. They're not, they're ontologically distinct from things. They're not just words for something else or something like that. We're taking these as really existing things. And that's important because these three things, these three criteria that I'm talking about here, are typically taken to be antithetical to the philosophy of mind that assumes physicalism, the idea that only physical things exist in philosophy of mind. If you have questions exactly what that means, please check out my video on physicalism. I'll explain all that stuff there. Our understanding would be something that's held by guys like emergentists, which Searle is an emergentist, dualists, hylomorphists, and idealists. But these things are taken to be antithetical to that, so it's important that we distinguish exactly what we mean by understanding. Do we mean our understanding? Do we mean P understanding? Do we mean a combination of both? What is it that, given these arguments that we're going to talk about soon, what is it that we're trying to say that computers are doing when we say that they understand? Okay, given that, first let me run through the argument for strong artificial intelligence. Strong artificial intelligence would be the idea that computers basically can understand, that they can think and they have minds and those kinds of things. Premise number one, understanding is nothing more than P understanding. And this claim is the central claim of a philosophy of mind called computational theory of mind, which is to say that when we say the word mind, when we're using that word, all we mean is something's running a program that takes certain inputs, spits out certain behaviors for outputs or something like that. It's just P understanding. So that would mean this would discount our understanding. It would exclude our understanding. So we don't have consciousness. We don't have intentionality, at least in the way a realist would use those words. Premise 2, a computer can P understand, especially something like Chinese, which is going to be what we're really interested in this video. So the conclusion, number 3, a computer can understand Chinese or whatever it is. Now, if this sounds shocking, if the conclusion here sounds shocking, that's probably because we're confused on what it's saying. What it's not claiming is that a computer can compute, therefore it has a mind, like it is actually experiencing things, like it's conscious of what it understands, like it is thinking about something. We're not saying that with the conclusion here. Instead, the shocking one should be number 1, which is to say those things that I just talked about, being conscious of what you understand, that qualitative feeling of, oh, I get it now, that humans don't have that is not part of understanding, that not just is that is not part of understanding, but that is not part of the human at all. Like, we don't have experiences, we don't have intentionality, we don't have any of those kinds of things. So really that would be the surprising one. And so what we're claiming here is less that a computer is what a human we typically would think is, and more that a human is what a computer we typically take to mean is, sort of bring humans down to the computer level. And so the conclusion sort of follows that, yeah, if all that a human does is just what a computer does, then of course a computer understands the same way that a human does. Now, Searle's Chinese room argument, I think, takes aim at 2 things: the computational theory of mind and strong artificial intelligence. So here's what I think it looks like. Here's my summary of the argument. If premise 1 is true from the strong artificial intelligence argument, then we can't P understand without understanding, right? If the 2 things are identical, if understanding is nothing but P understanding, then if you P understand, then you must understand as well. 5, I can P understand Chinese. I can, run a program and take certain inputs and spit out certain behaviors that are we typically would associate with understanding Chinese without actually understanding Chinese. 6, therefore, premise 1 is false. And remember, that was the computational theory of mind. The conclusion here is rejecting that. 7, the only thing that a computer can do is P understand. Therefore, 8, a computer cannot truly understand. A computer doesn't understand what it's doing. Now, as I said, 4 through 6 are a rejection of computational theory of mind. And then you add 7 in there, premise 7, and 8 is a rejection of strong artificial intelligence, the idea that computers actually understand in the way that a human understands. Of course, 5 here is the spicy one. That's the one that people are going to take issue with. So how does Searle support this premise? With the Chinese room counterexample. Now, I don't understand any Chinese. Well, I know ni hao and shi shi because Esther Shi, the Chinese teacher, once taught that to me, but that's all I know. So let's say one day I pass out, and when I come to, I am now in a totally sealed off room, except for like a tiny chute on one side of the room and a tiny chute on the other side of the room. And in this room, it's populated by a number of boxes with Chinese symbols on them. And I don't know what any of them mean. I've never read Chinese symbols before in my life, so I don't know them. And there's one big fat book filled with Chinese symbols, and kind of show you, like, if with certain Chinese symbols, what you should change them into. But I don't really know what any of this is. Now, somebody starts to put Chinese symbols into the little hole in one side of the room. I look at them, and then I look at my book here and I match them up, and I say, oh, when I have these symbols, I pick up some of the boxes that I've got, right? And I say, I'm supposed to use these symbols. So then I put them through the other little hole on the other side of the room. Now, little do I know, the boxes that came in were a question in Chinese, and what I gave out was the answer, a correct answer to that question. And every time somebody puts a question through that hole on the side, I'll look at my instructions here and I'll put out the right answer or a correct answer or an answer that makes sense, at least through the hole on the other side. But notice what I'm doing here is actually P understanding Chinese. This is exactly what a computer does, Searle says. You get an input from one side of the room. You have a program, which is this book that sets all the rules for the behaviors that you should have. And you have a database. You have all these blocks that you're using down to translate. And then you put out some kind of behavior, some kind of output through the other room. And it's exactly the kind of behavior we would associate with somebody who understood Chinese. So by definition, this is P understanding Chinese. And yet, I myself do not understand Chinese. And so Searle argues we can P understand Chinese without actually understanding Chinese. But that's premise 5. But that means that, understanding must not be nothing but P understanding, which is 6. And therefore, since that's all a computer can do, that computers can't actually understand, which is 8, the conclusion there. So this is Searle's Chinese room argument against, number 1, the computational theory of mind, and number 2, strong artificial intelligence, the idea that computers can understand the way humans understand. His argument is meant to show that computers will never be able to understand. It doesn't matter how good the technology gets. One important point I want to make about the way I framed this argument, the way I presented it, is that it was all first person. I said, I don't understand Chinese. I think that's important because although we don't need to claim that true understanding is our understanding versus P understanding, at the same time, our understanding is a viable option here. It's the one that Searle wants. So our understanding is something that is only first person accessible. You can't look at somebody else's consciousness. You can't perceive somebody else's intentionality, those kinds of things. You can't have access to those things. You can only have access to your own. So although Searle doesn't always put his argument this way, I think it's important that we frame it as a first person type of an argument. Now, there are 5 types of replies to the Chinese room argument. The first one we'll talk about today is the systems reply. The idea is this: in the Chinese room thought experiment, I am not the whole system of the Chinese room. I'm just like the analog of a CPU for a computer, so I'm not the whole thing itself. And the systems reply would say it's the whole system that P understands Chinese, not me, right? The whole system together is implementing this program, and I'm just part of the implementer. I am the implementor of the entire program, but I'm not the whole system itself. So the system P understands, and that changes 5 to, well, we'll call it here 5-star. The Chinese room, P understands Chinese, I don't understand Chinese. So now notice that invalidates the argument here. And if you're confused about conditionals, you can check out my course on logic. I explain all about these kinds of things. But the idea here is this: the force of this argument is that we have the same physical system, both P understanding Chinese and not understanding Chinese. So if it's the same thing that P understands but doesn't understand, well, that's devastating to the computational theory of mind because it said those two things were identical. But now we have 2 different physical systems. Even though they overlap in some way, I'm in both of them. I am one of them and I'm in the other one. They're 2 different physical systems. So no longer is it the case that you have the same thing and it's doing one thing but not doing another. Now you have 2 different systems, and it shouldn't be surprising that I don't understand Chinese because I don't P understand Chinese either. The Chinese room does. Now Searle has an interesting objection to this reply, which is that, okay, maybe in that example, I'm not the entire physical system, but I could be. What if I just memorized all the rules? I don't know what any of these words mean. I still don't understand Chinese, but now I'm the only physical aspect of this system, right? I am the physical system now that I have memorized the program. I'm implementing the program. You give me the Chinese words, I give you the correct answers, but I don't know what the heck's going on. So by definition, since I'm running this program, I have the same behaviors of someone who would understand Chinese for real, and I don't understand Chinese. Now it looks like I obviate that objection, or I obviate that reply because I have the same physical system that both P understands and doesn't actually understand. There's also a reply to this objection called the virtual mind reply. And it goes something like this. Imagine, I'm going to adapt it a little bit, and imagine you have a computer that has a video game on it, and in this video game, one of the characters speaks Chinese, and you can actually, your character can speak to it in Chinese and it will respond the way that you would think that a person who does understand Chinese would respond. So given our definition of P understanding, this character, P, understands Chinese. And yet the computer as a whole, you can't speak to in Chinese and it gives you the right behaviors. So, it answers the way a Chinese understander would answer you. So we could say that there's a virtual mind here, right? The character is not the computer, and the character understands Chinese, and the computer does not understand Chinese, does not P understand Chinese. And in the same way, you could say that I, running this program, even though I don't actually understand Chinese, there's a virtual mind inside of me that does understand Chinese because it's doing all the things that you would associate with someone who understands Chinese. Now, personally, I don't think it's a great reply, and here's why. By definition, it's a physical system that is running a program that gives you the right behaviors. The character in the video game is not a physical system running a program. The character in the video game is just a program itself. So it would be the computer that P understands because it's the only physical thing running a program. And in the same way for me, I'm just a sack of atoms here that doesn't understand Chinese, and it's the same sack of atoms that would P understand Chinese. So by definition of what, computational theory of mind is, I P understand, and yet I absolutely do not understand Chinese. Now there's another interesting support you could give for premise 5, along the same lines of the Chinese room argument, but it really focuses more on one aspect of understanding, which is intentionality that we talked about in our understanding. One thing that seems like is missing from P understanding of Chinese, the way that me in the Chinese room understands Chinese, is that there's nothing that these words are about for me. I'm just moving symbols around, but I'm not thinking about. So for example, I move the word for hamburger, which I learned was han bao bao. And feel free to make fun of me, Chinese speakers, because I have no idea how I'm actually pronouncing that. I speak Spanish, so I totally get when people butcher your language. No problem, make fun all you want. But han bao bao, and I move the han bao bao symbol, and I don't know what it is. So let's say somebody asks me in English, hey, what do they serve at In-N-Out? And I answer, oh, manna from heaven, hamburgers, right? These amazing hamburgers that they have. And I in my mind, I can picture those hamburgers, right? When I use the word hamburger, when I produce that behavior, there's some content to that. There's something that thought is about and that my language is about. But when you ask me the same question in Chinese and I answer han bao bao, then there's no content to that word. I don't mean anything by it. My concepts are totally empty when I'm using this term han bao bao, right? So it seems like it's missing something, that P understanding of Chinese that I have when I do understand, for example, the word hamburger in English. And that would be content, mental content. So given that, the second reply we'll talk about is the robot reply, which is to this specific problem, this specific aspect of the argument. This objection makes sense when we're talking about a computer that is isolated from the real world. But what if we had a computer that was, let's say, in the head of a robot, and the robot has 2 cameras and is scouring the place and comes upon a hamburger, right? And the photons from the hamburger cause a specific image to be conveyed to the cameras, and the computer associates han bao bao with that specific image. And every time that the computer says han bao bao, when it follows the program and spits out that word, it also maybe displays the image of han bao bao. And all of a sudden we have content. Because we have some real world object that causes something in the robot and associates that specific word, and that is what's, part of that's being recalled every time we have this this word used, then we can say in that way, it's kind of like we have content, right? It should be noted, however, when we say that this is a type of intentionality or a type of content, we don't really mean the same thing that we were talking about before, right? We don't mean that the computer actually is when it says han bao bao, it's thinking about a hamburger or in any way. Instead, what's happening is that the hamburger has caused the computer to have a specific kind of an image, and whenever the microphone of this computer is affected by sound waves that make the sound han bao bao, runs a program that causes it to project a specific kind of an image, a hamburger image. But it's not like the computer's sitting there like looking at, oh wow, there's my image. It's just projecting this thing. So this we'll call the causal view of mental content, or the causal theory of intentionality. We'll call it C for short, C intentionality. Let's say we add this criterion to our definition of understanding. We're changing it a little bit. Before it was the computational theory of understanding, the P understanding, right? You just run a program, get the right behaviors, you understand. This would be adding one more criteria, which would be, we'll call this C or CI understanding, right? You also have to have causal intentionality when associated with the words that you produce in your program. So if we're going to have both of those criteria together, we'll call it PCI understanding. And remember, adding this criterion of causal intentionality was meant to address the intentionality problem. However, you can actually run another Chinese room argument very similar to Searle's argument before for this specific problem. So consider premise 9 here. If intentionality is nothing more than causal intentionality, or C intentionality, then we can't have causal intentionality without also having intentionality. However, I can have causal intentionality of, for example, the word han bao bao without having actual intentionality about that word. So causal intentionality is not identical to intentionality, but all the computer can have is causal intentionality. Therefore, a computer can't have actual intentionality. And of course, the one that people aren't going to like here is premise 10. But again, we can give something very similar to the Chinese room thought experiment to support this premise. We'll call this one the internalized Chinese room robot. So now I've memorized all this program that takes the Chinese questions and gives you the Chinese answers. Let's say I've also internalized a program about ones and zeros, about digital kind of language that takes that ones and zeros and translates them into these Chinese characters. So if I get a specific kind of readout, I'll know what the Chinese character is for that readout, but I won't know what that thing is. Now, stuff me into the head of this robot here. And the robot looks at the hamburger and the photons hit the camera. Let's say the same digital readout that is given to the computer of the robot is printed out onto a little piece of paper that I can see. And this is part of the program that I memorized. I know what the Chinese characters are for this, and then I give you the correct ones. I give you that output, and the robot says han bao bao, and so I would have the causal intentionality. I would have my word han bao bao that I memorized in my program associated with this digital readout, which was caused by the hamburger itself, and yet I have no idea what we're talking about here, right? I have no actual intentionality. There's no content to this word han bao bao, which would be different if instead of the digital readout, somebody said, hey, there's a hamburger here. I would be, oh, hamburger, sweet. And I'd have, content in my mind. So the idea is here, I would have causal intentionality without having actual intentionality. The next reply, we'll look at the brain simulator reply. So let's say that we aren't convinced that the program is enough for the computer to understand, and the causal intentionality is not enough for the computer to understand. What can there be for this computer to convince us that it understands in the same way that we understand? Well, one possibility is that it could just mimic a brain like we have. Imagine a computer that takes as input actual sentences, characters that in Chinese that a normal person would say. And imagine that this computer has a program that replicates the way that a Chinese speaker's brain works. The same nerve firings that happen when the Chinese speaker hears the sentence, and the same pathways that are ignited, and then the same outputs as the Chinese speaker would give. Well, so now the computer works exactly in the same way that the Chinese speaker's brain works. So shouldn't we say that it understands just like the Chinese speaker does? Here it is in a little bit more logical detail. 14, a computer brain simulator works in the exact same way as a Chinese speaker. Let's say Dan Ao. Dan Ao is a buddy of mine that is Chinese. The same way that Dan Ao's brain works. Now, Dan Ao understands Chinese specifically because of the way that his brain works. Therefore, the computer also understands Chinese. Now, we will have to nail down what we mean by this in the same way criterion, because clearly we don't mean by in the same way using the same stuff, right? Because the computer does not use neurons for real. So what do we mean by in the same way? And probably the number one criterion given is complexity, in the same complexity of the brain. The brain is an interconnected physical system. And maybe the understanding only comes when we get the right kind of interconnectedness. Now, of course, it couldn't be just complexity by itself. So what if we actually put all these things together, all these criteria into one big, delicious understanding definition? Now, we could call this PCIX understanding, P6 or PKIX. I'm coming up with the names here and I don't know how to pronounce them. The P part of the understands is that, runs the program with the right kinds of behavior. The CI part of the understands is that it has causal intentionality. And the X part, it has the same kind of complexity as the brain of a person that we would associate with understanding Chinese. The problem I see with this reply is that the only thing that we've added here is that the program is now super complex. So it seems like the same internalized Chinese room robot thought experiment would work here except for the complexity part. And the only reason that's not going to work for me is because I ain't that smart. But you could imagine a super genius, right? Somebody who is super, super smart, super, super quick, and can come up with all these calculations in their, the Rain Man kind of a situation. So we'll call this the super genius internalized Chinese room robot and run the exact same thought experiment, only the program that's internalized here is in the exact same structure as the brain. And if we really wanted to, we could take all these different criteria and just rework the Chinese room argument from before. 4-star, if understanding is nothing but P6 understanding, then I can't P6 understand without understanding. However, 5-star, I can P6 understand Chinese without understanding Chinese. Therefore, 6-star, it's getting hard to keep track of these numbers. Understanding is not just P6 understanding. 7-star, the best that a computer can do is P6 understand. Therefore, 8-star, a computer can never understand. John Searle, by the way, gives another objection to this reply, which is, it's kind of I think takes it off of the track of what the original argument is. Imagine that instead of using a program with all the right complexity, instead this guy is using a water valves with all the same exact complexity of a neural network, and the program tells you, which water valves to open given the digital content that comes out, and just you can open it in the exact same way that your neurons would fire if you heard a specific word and you understood Chinese. So I don't like it because now he's no longer the physical system, and now what we're left with this just sort of intuitive argument, which is like, yeah, but water can't understand. I agree, water can't understand, but that's not the point of this argument, at least as far as I understand it. So and I can explain that more on the website if you're interested in that. The fourth reply is the other mind's reply, and it goes something like this. We attribute understanding to other people because of behavior. But by hypothesis here, our robot can produce those exact same kinds of behavior. Therefore, we should attribute understanding to our robot. One thing I want to point out before I go any further, though, is that notice that we've actually gone away from P6 understanding with this objection here. Now we've come back to our understanding. Remember what the original debate was. It wasn't whether computers could R understand or not. The original debate was just, is P understanding the only kind of understanding, or for in our case now, P6 understanding the only kind of understanding. But the problem of other minds isn't whether they P6 understand or not. The problem of other minds is I can't see into your head and see what you experience. I don't know that you're not just producing behavior that I would associate with understanding instead of having like a qualitative experience of, oh, I totally get it. Maybe you're just saying, oh, I totally get it, and you don't actually get it. Maybe that's just the program that you're running. That's the problem of other minds. There's no debate about whether a computer is P6 understanding at all. So the only debate here could be whether it R understands. So that's the only reason that the problem of other minds would even apply to this debate. And that's taking us well beyond what the computational theorist wants. They don't want that. But a strong AI theorist might want that. Somebody who says that a computer does have a mind might want to say that, yeah, a computer can have a conscious experience. It can have content to its words and to its speech. So a strong AI theorist might want to say that a computer has an R mind or can have an R mind. Now, applying the problem of other minds here, it can be pretty tricky. Why should we say that these things have other minds when sure they have the same behavior as us, but they still have this sort of funky genesis here. So, we still are left with this kind of, I don't know, it's not quite the same thing. And typically the reason that's given here is really just pragmatic reasons. So, why say that Siri understands Chinese? Well, because thinking of it that way, attributing a mind to this thing will be helpful in predicting its behavior. So when Dan Al asks it, hey, where's the nearest Han Bao Bao? I'll kind of know what is going to happen if I say, it understands you, Dan, or no, it doesn't understand you, Dan. So to say that Siri understands Chinese is just helpful in the same way that I say that Dan Al understands Chinese, even though I can't see inside of their minds to see if they are understanding. I think the big problem with that is, I'm sure it's useful to do that, but this is anthropomorphizing, which is very useful, but it's purely metaphoric. For example, if I were to tell you that In-N-Out wants to sell Han Bao Baos in San Clemente, well, it's not that I'm saying that In-N-Out is a real thing that has these feelings, these desires that it wants to accomplish before it dies. That's not what I mean. I'm using the word wants in this case, and I'm referring to In-N-Out just because it's useful, because it's easy to talk that way. It doesn't mean that I think that wants is a real thing when I'm referring to In-N-Out. So even though it's useful to talk that way, we typically wouldn't take that as serious talk. In any case, that is the other minds reply. The final reply we'll talk about is the intuition reply. And by the way, when I say intuition in philosophy, I don't mean I just had an intuition about it. If I were to say something like, intuitively speaking, 2 + 2 = 4, what I'm saying here is that I'm not proving it to you that 2 + 2 = 4, but I see it, right? I conceptually can picture it in some way. It's not a great explanation of intuition, but something around and about that. Well, the reply here is that the Chinese room argument is using intuition here, right? It's playing on our intuitions about what can and what can't have a mind. And yet intuitions aren't very reliable when we're talking about very outré kind of stuff, very wacky kinds of things like this. They don't work there in the same way they don't work in, let's say, the quantum level. I have an intuition that two things that are separated by a distance can't affect each other, and yet there's quantum entanglement. So I don't know, my intuitions don't work at that level in the same way they wouldn't work in recherche metaphysics. So the Chinese room argument can't be trusted. But the computational theory of mind is very useful. It has great explanatory power, right? It sort of explains how behaviors come about. And we should believe in things that have the best explanatory power. Therefore, we should believe in the computational theory of mind over the Chinese room objection to it. I actually think there are a number of objections that you can give to this reply. But just to save us some time here, I would say remember that me framing it in the first person is doing away with intuitions. What I'm saying is I observe myself using certain words without understanding, but with the right behaviors, and using certain words with understanding and the right behavior. And I observe that these two things are different. I observe that there's something different with me P6 understanding versus me actually understanding. So I'm not really appealing to intuitions at all. I'm appealing to direct observation. Now, there's much more to be said about each one of these replies, and it's kind of crazy how much that you could say about this stuff. But I mean, man, I'm sure this is going to be a massive episode. So if you have any questions, don't forget, hit me up in the comments, and I'll send you a link on where I'm going to talk about it on my website. If you know anybody that is interested in philosophy of mind or artificial intelligence or any kind of thing like that, please go ahead and tag them or send this link to them so that they can join in the conversation. Again, this is one of my favorite things, this thought experiment right here. So I love to talk about it, so I'd love to talk to you about it. But in any case, that's all I got for today. See you next time. Adios.